Let's look at this problem. Suppose we have two variables, x and y, and they satisfy the following two equations. We want to find the value of x plus y. I think for most students, the first impression about the problem is to solve this system of equations. Since this system is just a system of two linear equations, therefore, it shall not be too hard to do it. However, after some initial trial, I guess most of you may find that it is not so straightforward. You spend a lot of time on simplifying the solutions because the coefficients of these two variables, x and y, can grow really big. Therefore, the conclusion we can draw in here is that we can certainly do this to solve this system of equations directly and get the values of x and y and then sum them up. That will certainly be a doable approach. However, to do this approach may not be the most efficient one, and it may cost you a lot of time in the actual exam. So in this video, we will not choose that approach. At the same time, by checking the forms of these two equations, we realize that these two equations have some very special structure. The coefficients of each variable in each equation takes the form of a fraction, and the denominators of each fraction is the sum of two exponentials. It may sound quite complicated. However, all of such coefficients are simply some combinations of these four components: 4 cube, 5 cube, 6 cube, and 7 cube, right? Therefore, we don't want to calculate the sum of the exponential numbers like these, because such a calculation can break this structure and we may lose track of the patterns hidden in such a structure. And in order to proceed our analysis, we want to rewrite these two equations in a different form so that we will remove all of these fractions and convert all the coefficients in the form of integers. And that will help us to separate these four components. And it will also help us to do the next step analysis. So for the first equation, let's multiply the product of these two sums on both sides of the equation. And it will become 4 cube plus 7 cube times x plus 4 cube plus 6 cube times y. And that equals 4 cube plus 6 cube times 4 cube plus 7 cube. Good. And similarly, we will do the same thing to the second equation by multiplying the common denominator on both sides of the equation. So we'll get 5 cube plus 7 cube times x plus 5 cube plus 6 cube times y, which equals 5 cube plus 6 cube times 5 cube plus 7 cube. Then we have convert the original two equations to this equivalent system of equations. And we want to call the first equation as equation 1, and then refer the second equation as equation 2. And this is the place where we diverge in the rest of our analysis. And certainly for some students, you can still choose to do the brute force way. But in this video, we will introduce two different ways to handle this problem. And let's look at them one by one. So basically, each of these two methods will focus on different aspects of this system of equations. In method 1, we have a couple of interesting observations about this system of equations. And don't forget, In the beginning of our analysis, we found that these four components are the building blocks of the original structure. Therefore, we want to focus on these four components. And in equation 1, we find that this component, 4 cube, it appears in every of the terms in this equation. And in equation 2, 5 cube has the most occurrences, right? And it appears in every term of this equation. Therefore, we find that the first two components, these two, has some specialties in them. So let's put it down. There is some difference between the frequency of occurrences of the two components, 4 cube and 5 cube. And in the second place, we find that these two equations are almost identical except these two terms, 4 cube and 5 cube. So if we cover up these two components, these and these two equations are virtually identical. Therefore, these two equations, 1 and 2, show some properties of symmetry about the two components of 4 cube and 5 cube. And such observations can motivate us to combine these two equations in one by defining a new variable. So let's see how it works. So what we want to do is to replace this 4 cube in the first equation or 5 cube in the second equation by a new defined variable t. Then both equations can be written in the same format of t plus 7 cube times x plus t plus 6 cube times y, which equals t plus 6 cube times t plus 7 cube. And we can retrieve the original two equations by substitute this t by 4 cube and 5 cube respectively. Therefore, we've combined the two equations as one quadratic equation. So let's put this down. This is a quadratic equation about the variable t. And this t has two different roots. So let's write this down. One is t1 equals 4 cube and t2 equals 5 cube. Therefore, in the next, we will focus on this quadratic equation and try to calculate the values of x plus y out of this equation. And let's take a look how it works. So first of all, we want to collect the terms and rewrite this equation in a clean way. So let's expand these brackets. So let's look at the right-hand side of this equation. We only have the quadratic term out of the right-hand side. And we can certainly see that the coefficient of the quadratic term of t is 1. So it is t squared plus something times t. And we have different components about the coefficients of t. So from the right-hand side, we have a 6 cube. We also have a second cube, right? So 6 cube will be part of the coefficient, plus 7 cube is also part of the coefficient. And then let's look at the left-hand side. So if we expand these brackets, we will have an x here, and we will have a y here. Therefore, the rest components of this coefficient will be minus x and minus y, right? And then we will plus some constant terms. And finally, this equals 0. And in here, we want to save some time by skip this part, because In the rest of our analysis, this is not required. And now let's look at this term. Don't forget, all what we want to do is to find the sum of x and y. And this part is simply a sum of x and y. Therefore, we can write a new equality about x plus y by Vieta's formula. So, by Vieta's formula, we will have t1 plus t2, which equals minus 6 cubed plus 7 cubed minus x and minus y. And don't forget, the two roots about this quadratic equation about t is known, and they are 4 cubed and 5 cubed. So let's plug in these two roots into this new equality. So we'll have 4 cubed and 5 cubed here. And let's clean up the right hand side. We'll have x plus y minus 6 cubed minus 7 cubed. Therefore, we can solve the sum of x and y out of this equality. So we'll have x plus y equals 4 cubed plus 5 cubed. So they are basically from here. Alright, and then plus 6 cubed plus 7 cubed. Therefore, this is our final solution. This is exactly what we want. This is certainly a very clever approach which combined these two equations into one quadratic equation. And then the rest of the work is Vieta's formula. And now let's look at the second approach, M2. So in M2, we will look at this system of equations in a different angle. So let's use a different color. We are talking about the same system of equations. And at this time, we want to read the coefficients of x and y about these two equations very carefully. And this is because that we have found that the whole structure of these two equations is formed by these four components. Therefore, we want to convert the coefficients of x the same as the coefficient of y. And then we can factor out these common coefficients, and the rest of the work will be very straightforward. And let's look at these coefficients one by one. So for this coefficient about x, we have this 4 cubed and 7 cubed. And this coefficient of x, we have 5 cubed and 7 cubed as well. Therefore, if we take a difference between these two equations, we can eliminate this component, 7 cubed. And similarly, by the same operation, we can also eliminate this 6 cubed from the coefficients of y. And the remaining coefficients of x and of y will both become 5 cubed minus 4 cubed. And this is exactly what we want. So let's put it down. So in the second approach, let's do this. We subtract equation 1 from equation 2. And what we get is this. We have 5 cubed minus 4 cubed times x plus 5 cubed minus 4 cubed times y, which equals 5 cubed plus 6 cubed times 5 cubed plus 7 cubed. This is the right-hand side of the second equation, minus the right-hand side of the first equation, which is 4 cubed plus 6 cubed times 4 cubed plus 7 cubed. Very good. And now we want to factorize this common coefficients of x and y. So we have 5 cubed minus 4 cubed times x plus y. And up to this step, we shall be very confident that we can solve the value of x plus y by simplifying the right-hand side of this equation. And we want to expand these brackets. From the first product, we have 5 to the 6 plus 5 cubed times 7 cubed plus 6 cubed times 5 cubed. And we want to skip the fourth expression because the product of these two, 6 cubed times 7 cubed, will cancel out from the product of the same two quantities, 6 cubed and 7 cubed. Therefore, let's skip it. And let's continue to write the expansion of the second product. And we'll have 4 to the 6 minus 4 cubed times 7 cubed minus 6 cubed times 4 cubed. And up to now, I guess the rest of the calculation will be very straightforward because the target on the right-hand side will be to factorize such an expression out, and then we'll get the result right away. And it'll be very easy to find what to do. So firstly, we want to pair up these two quantities. So we have 5 to the 6 minus 4 to the 6. So this is certainly a square difference, and we can factor out this common coefficients of x and y easily. And secondly, we want to combine these two terms by factoring out 7 cubed. And then we'll have 5 cubed minus 4 cubed left. And this is exactly what we want. Similarly, let's combine these two terms by factoring this 6 cubed out. So plus 6 cubed times 5 cubed minus 4 cubed. Therefore, we can combine these three terms by factoring out this 5 cubed minus 4 cubed, and then times 5 cubed plus 4 cubed. These two terms is from the factorization of this square difference, and then plus 7 cubed from this expression, and plus 6 cubed from the last expression. So this is our result. Therefore, we find this common factor on both sides of the equation. So let's divide this common factor from both sides. So this will cancel out. Therefore, our final result is x plus y equals 4 cubed plus 5 cubed plus 6 cubed plus 7 cubed. And this is our final result. And it is identical to what we got from the first approach. Very good. So up to now, we've found two ways to solve this problem. And before we end this video, we want to do a quick sum up. And by analyzing the original system of equations, we find that to solve this system directly and find the values of x and y will be very inefficient. Therefore, we rewrite the original system of equations in this new format. And we found two approaches to solve this problem by looking at different aspects of the same system. In the first method, we are focusing on these four important components of this structure: 4 cubed, 5 cubed, 6 cubed, and 7 cubed. And we find that these two equations are symmetric about the first two components, 4 cubed and 5 cubed. Therefore, we successfully combine the two equations into one quadratic equation of a new variable t. And then the rest of the work will be straightforward. we apply Vieta's formula to solve this x plus y out of the coefficient of t. While in the second method, we found a way to make the coefficients of x and y the same by subtracting the first equation from the second equation. Therefore, we can factor out these common coefficients, which is this thing, 5 cubed minus 4 cubed. And then by collecting the terms on the right-hand side and do some proper factorization, we can solve x plus y easily out of this expression. Therefore, we want to call the first approach a very clever approach, a clever way, and the second approach a very straightforward approach, or a direct method. If you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.